This is a combined class for section 2 and section 3. And last class for one section, little bit discussion was there about linear programming. It may be a repetition for some of you, but hardly that repetition may be for a few minutes. So in reality, this actually, I want to finish this one for section 2 and section 3 today. Next week there will be any class. And by the way, how was your exam? Moodle, you appeared. How was your that exam? My portion, is it too easy? Very, very simple. I do not remember exactly all the questions, but I think there were 8 questions from my side. And I feel it is easy in my portion. Might be 1 or 2 numerical question related to, might be elasticity, as I said also. And in your last exam also, there will be numerical problem. Okay. And if it is in Moodle, mostly it will be multiple choice maybe, but I'm not sure whether it will be in Moodle or it may be in online mode. It will be online, but it may be just like in other subject how I am doing it. I am sending that question paper to students. So I do not know exactly what is that. We are yet to take a decision, but maybe some portion may be in Moodle, or maybe in Moodle itself it may be. Anyway, that Professor Sahu will circulate, whatever will be that mode and everything. But obviously it is online, that is known. And the schedule will be as per the institute's instruction, means that schedule, that exam schedule will be decided centrally about that one, between 7 to 13. Just to avoid any overlapping. Anyway, so when we talk about optimization technique, why it is important? For one section, I said it little bit. That is that sometime in my first lecture, I said that your resources are limited. With your limited resource, you want to maximize your, with your limited resource, you want to maximize your profit. For profit, you are doing a business, suppose. Then profit maximization may be your objective. And that profit maximization, you can do it maybe by optimal utilization of your resource to the best level you want to utilize those resources. And many a times what happen, maybe by minimizing cost of production, you can maximize your profit, because you, as I say, total revenue is nothing but profit is nothing but your total revenue minus total cost. Total revenue is what? P into Q. P is the market price. Q is the output. Market price in a competitive market, you have limited role to play. You cannot manipulate the market price because market is competitive. If you manipulate, other player will supply more. Suppose you are increasing price of your product. Similar products are there in market. They will reduce their price or they will keep their price at same level. Ultimately, demand for your product will drastically decrease. It will be highly elastic. So your role with respect to, in a competitive market, your role to play with price is very, very limited. So only your option is either to manipulate output, Q, because that is you are producing. You can produce 0, you can produce 1 million. It's up to you. But sometimes you need to think about the level of output you can sell in market. Sometimes market is like that, you can sell only 1,000 units of a product. Then producing more will destabilize the market. So what you are doing is, you will try to produce 1,000 units only to supply, but with minimum cost. So cost minimization, because total revenue minus total cost. If cost component is less, then profit will be more. So you will try to produce 1,000 units with minimum cost. So sometimes cost minimization may be your objective. Ultimate objective is profit maximization, but profit maximization you are doing it by minimizing cost of production. That may be one option. And sometimes what happens, just like in perfect market, what you realize that if you are ready to accept the prevailing market price, you can sell unlimited quantity of your product, unlimited quantity in a market. So if this is the case, that unlimited quantity you can sell, profit may be more or less fixed, maybe. Say per unit you are making a profit of, say, 2 rupee. Then instead of selling 1,000 units, if you are in a position to sell maybe 1 million unit, 1 million into 2 million will be your profit. So in that case, total per unit profit is fixed, but you are producing more. And as you know, when you are producing at large scale, economies of scale is appearing most of the cases. Means cost of production is not proportionately increasing. So optimal utilization of resources is taking place, better and better utilization, maybe production in 2 shifts. When you are producing in 2 shifts, same building you are using it, or same space, same machine you are using it. So many of these fixed inputs are not reappearing, or proportionally it is not increasing, because some of the things are you are utilizing in a better way. Room rent is not increasing. Already I explained. Anyway, so here comes your linear programming or optimization technique. It is a technique. Okay, it is a technique. It gives a numerical solution, specific numerical solution, and under nonlinear programming, you may find that a nonlinear relationship also. As it is a linear programming we are discussing, here most of the cases we assume that, means all the cases we assume that relationship is linear in nature. But it may be nonlinear programming also. This discussion is from A. Kochenis, that particular book, Modern Microeconomics. Towards the end, you will find one reference also. And but there you will find lot of things. Here I summarized it, and many of the things I excluded it. Like there are different techniques discussed, like simplex method, reverse simplex method, matrix algebra. They use it to solve the problem, linear programming problem, or conversion from primal to dual. Those things here only I mentioned it, but I will try to solve it graphically only, quickly. Now here, linear, it is a mathematical technique for solving constraint maximization or minimization problem. As I said that your resources are limited, so it is a different constraints you face it in production. And maximization, minimization, already I mentioned that profit maximization or cost minimization, so and so. When there are many constraints and the objective functions to be optimized, because you want to optimize your production so that your profit will be maximum or cost will be minimum. That may be your basic objective. Okay. And constraints faced are linear, means here we assumed a straight line or relationship is linear, we assumed. You will find it after some time when we will start writing it. It is a technique for providing specific numerical solution of problem, means it will give you specific solution only. It is not telling you how to produce, how much to produce. Then these are your managerial decisions. So it bridges the gap between abstract economic theory and managerial decision making. Means it is not directly telling you how to produce. It is telling you that if you produce this much, your profit will be maximum under this given condition. Given condition means constraints. What are these constraints? Suppose your labor is 400 units, machine hour is 300 units. Land is 1,000 square feet of land. Limitedness of your resource. The moment you spell out any value, limitedness is coming into picture. Okay. So in this case, what is happening? Your resources are limited, and these are basically constraints in production. So under a given constraints, if you produce, because labor, as I said earlier also to other section, that labor can be utilized in n different activities. So there is always a concept of shadow price and opportunity cost is involved here. I will come to that point also towards the end. I'm just skipping it. The Russian mathematician developed it. It is because of use of software. It is very, very popular. Nothing else to discuss. And please remember this PPT I will share with you in your class material. And question from this linear programming will also be there in your next test. Okay, because in the last test yesterday I didn't set any this one, or on Tuesday I didn't set any question. Okay, but next class definitely question will be there from even this like discussion also. So difference between traditional economic analysis versus linear programming. Both approaches show how economic agents reach optimal choices. Economic agent means producer and consumer. How they do their planning or programming in order to attain maximum utility, maximum profit, minimum cost. These are objectives. Sometimes utility maximization may be your objective. But neither economic theory nor linear programming say anything about the implementation of the optimal plan or solution. They simply derive the optimal solution in a particular situation. Means these are the resources given to you. Under this given best utilization of resource, if you think about, then how many units of this, suppose two commodities you are producing, how many units of commodity X and how many units of commodity Y you will produce, so that under this given resource constraint your profit will be maximum. So, however, in economic theory, optimal solution is usually shown in qualitative abstract term, diagram, or general mathematical symbol in economic theory. But in linear programming, as name says, it yields specific numerical solution to the particular optimization problem. Relationship of economic theory are usually non-linear, expressed by curve, while in linear programming, it is linear. But please remember, we are discussing linear programming, because of that we are assuming that it is linear. But if we discuss non-linear programming, that is another day, it is there. Then this second difference will not be that much valid. So I am coming to our framing of that linear programming problem. Okay, I will try to frame it first, or after that we will try to solve it graphically quickly, and I will move to your visualizer also in between for drawing. Suppose this information is given to you: 400 unit of labor, 300 unit of capital, and machine hour, and 1000 square feet of land for producing two commodities X and Y. Okay, make it simple way. Activity A means production of X is termed as activity A, and production of Y is termed as activity B. But otherwise, you can make it more simple, like you are producing straightway using land, labor, capital. You are producing two commodity X and Y. To produce 1 unit of X, you require 4 labor hour, 1 machine hour, and 2 square feet of land. To produce 1 unit of Y, you require 1 labor hour, 1 machine hour, and 5 square feet of land. This sentence is just the discussion, nothing. Just remember those values. Along with that, another information is given, that is per unit profit. In a questionnaire book, in per unit profit, you will get it in US dollar. Here I made it INR only. Per unit profit of X is 2 rupees and per unit profit of Y is 1 rupee. So if per unit profit is there, but we do not know the level of X and Y, how many units, that solution actually linear programming will give us. How many units of X and how many units of Y we will produce, so that our profit will be maximum. If we assume that Z is my total profit, then I can write the profit function as Z equal to 2X plus 1. 2 is the per unit profit, X we do not know the value, 1 is per unit profit of Y, and Y, level of Y we do not know. That we are going to get it by solving linear programming. That when you run it, when you have value, when you run it, fraction of second, computer will give the solution. But we are trying to discuss the mechanism. Okay. Now in this case, your objective function is profit, maximizing Z. Maximizing Z your objective function. Because we try to maximize your Z. We try to produce X and Y in such a way that Z will be maximum under this given constraints. Constraints means these are your constraints. Why it is constraints? Because you cannot go more than 1000 square feet of land. You can utilize 500 square feet of land, but you cannot go beyond 1000. If you go your solution will be totally different. So you cannot go beyond 1,000. So this is a limit, limitedness with respect to use of resources. So this is a constraint, constraints in production. And by chance, if you can manage more unit of that particular input, then your solution will be different altogether. So the total profit function is called the objective function. It expresses the objective of the firm. This is the function which represents the goal of the economic agent. In this case, producer, because we are talking about maximizing profit. Producer is producing or doing a business with a hope that his profit will be maximum. Okay. So two different kind of constraints you may find it. One is technical constraints, another is non-negativity constraints. Technical constraints are set by the state of technology and the availability of factors of production. In this case, three factors of production is there: land, labor, capital. So you are getting three factors of product, technical constraints. There are as many technical constraints as the factors of production. Three factors of production, you are getting three your technical constraints. They express the fact that quantities of factors will be absorbed in the production of the commodities cannot exceed the available quantity of this factor. Thus, you are getting these are supposed to be three different equation, you can say, or if not equation, at least three different expression you can say. 4x plus 1y is less than equal to 400. 1x plus 1y is less than equal to 300. 2x plus 5y is less than equal to 1000. From where it is getting? It is coming from these values. Now, I am moving to some other. I will come back to this one. Let me show you few slides, then I will come to visualization. Otherwise, again and again, I will move backward. These are technical constraints. How we are getting it, I am going to discuss it. Now, regarding non-negativity constraints, the meaning is your output cannot be negative. Means this X and Y cannot be negative. You are using land, labor, capital. If there is a misutilization in worst situation, you will get only zero output, no output. Or otherwise it will be positive. It cannot be negative. So that is explained by non-negativity constraint. So how to frame a linear programming problem then? This is like this. Maximize Z, because this is your objective. Maximizing Z, profit, total profit, equal to 2x plus 1y, subject to three different rows you express it. 4x plus 1y is less than equal to 400. 1x plus 1y is less than equal to 300, and 2x plus 5y is less than equal to 1000. These are three technical constraints and two non-negative. This is also in two rows. X is more than, to save some space only, I wrote it in this way. X is more than equal to 0, Y is more than equal to 0. So in linear programming, optimal solution is defined by examining a set of possible alternative solutions and eliminating gradually the suboptimal one until the optimal is reached. Means let's go back or go to our visualization. Let me just a minute. You sign it and pass it on to others. Online student, can you see it? Yes, sir. It may be smaller in size, but I am helpless actually. I'm not sure how much or how distinctly you can see. So what I was telling it, to produce 412, I think, and this was is 115, I think. Is it that unit requirement? How much? So what first equation talked about technical constraints means what is happened for this is for labor, this is for capital, and this is for land, LA for land, suppose. Okay, and this was your for X, this was for Y. To produce, so if we consider only land, or sorry, labor, to produce, you are having 400, maximum unit is given is 400. Okay, 400 unit of labor is given. We are considering only X and Y in this discussion because it is two-dimensional space. In reality, labor might be utilizing n different activities or to produce n different commodities. And in that case, definitely you cannot go even for matrix algebra. It will be very complicated calculation. So, but we are having limdip or other kind of software, very easily you can do it. Fraction of second. But I am making it in a very simple way here. So what is happening here? If you consider 400 unit of labor, you can utilize labor up to 400 unit. In this case, we assume that you are producing only two commodities. So if this is the case, then use of labor cannot be more than 400. It may be less than 400 or 400. Means you can utilize in your production of X and Y, you can utilize 300 unit of labor. No one will question you. It is your labor. You are spending money. Okay, or at the most you can go up to and produce maybe 400 unit of labor or utilize 400 unit of labor, but you cannot go beyond 400. That is the upper limit. So in this case, to produce 1 unit of X, you require 4 unit of labor. So I can express it like 4X plus 1Y is less than equal to 400. Okay. Similarly, here for capital also 1x plus 1y is less than equal to 300. Upper limit was given 300. In that way, technical constraints are coming. 2x plus 5y is less than equal to 1000 because here it is given 1000 square feet of land. Now, think about few cases here. Suppose, what will be that constraints if I try to draw a line? What will be that constraints for labor? Constraints for labor is 4x plus 1y is less than equal to 400. So, I may be a producer who might be producing only x, no y. One extreme case. I may be a producer who are producing only x, no y. Then what will happen? Y will be 0. Maximum unit of x with 400 unit of labor I will be able to produce is 100. So I will get a point somewhere here. Suppose this side is represents x and this is y. Suppose. And extreme case, another extreme case, x is 0, it will be 400 somewhere here. So if I join these two lines, I will get a diagram is not good, but anyway, this is that one. Okay, this is the constraints for labor. This is the constraints for labor. Okay. Now think about capital, machine hour. 1x plus 1y is 300. Means you will get a point somewhere here, another point will be here. If you join these 2 points, you will get another point like this. And this will be the point for capital. Similarly for land, 2x plus 5y is less than equal to 1000. The meaning of labor or meaning of capital, suppose labor is that any points you can reach beyond this line or on this line because it is 400. You cannot go beyond this line. This is the limitedness. For capital also, you cannot go beyond that line. Any point on this utilization of that resource. So in this case, it will be 2x plus 5y. If it is y is 0, it will be 5. So somewhere here you will get a point somewhere here, and in this case you will get a point somewhere here. So if I join these 2 points, you are getting another line. This is for land. So here any points on this line or below is possible for you to reach. The moment we are considering first quadrant, how to solve it? Now, problem you know it already. Framing that maximize z equal to 2x plus 1y, subject to these 3 technical constraints, and x and y, to our x and y is positive or equal to 0. The moment we consider first quadrant, non-negativity constraints is fulfilled. We are taking care about. Because in first quadrant, either x or y may be 0, or we are talking about solving the solution, means solving the linear programming problem. So it involves 3 steps, or 3 steps it involves. One is finding out the region of feasible solution, where feasible solution may be there. Feasible solution will be that particular area where all the constraints are fulfilled. So if all the constraints to be fulfilled means non-negativity as well as technical constraints, 3 technical constraints we have. Along with that, we need to fulfill the non-negativity constraints also. If we choose this particular area or region, here, this one, as well as this particular region, if we choose this particular area, shaded area maybe, its boundary, including its boundary line. The boundary line means this area, shaded area, green color, including boundary line. Then what is happening in this particular area? In this particular area, what is happening? All the technical constraints are fulfilled, because I can choose a point here, suppose. Then it will fulfill only land, but with respect to your labor and capital, it is outside that one, so it is not fulfilling. But in this particular shaded area or its boundary line, fulfilling all my technical constraints as well as non-negativity constraints. So this is the first condition, or that a feasible solution will be there where it is fulfilling that area where all the constraints are fulfilled. Okay. Second step is identifying your isoprofit line, because we know z equal to 2x plus 1y. We do not know the value of x and y. We do not know that, we are deciding. But we know slope of isoprofit line. Slope of isoprofit line, how it measure? Unit profit of x divided by unit profit of y. Means in this case, slope of z will be, or isoprofit line will be, slope with respect to isoprofit line will be 2 by 1 equal to 2. So you know the slope of the line. This is the second step. You know the slope of the line, but you do not know the level of x and y. But if you know slope of the line, then one thing you can do it, that is, I am not sure, but hopefully this color will work. Let's see. No, it is not visible that much. This will also be light.
Sir, slope is 2 or minus 2?
Slope is 2. Minus 2, obviously, slope will be, but so we see, in this case, ultimately you are getting a slope of 2. So what you are getting it might be this one will work. Let's see. So what you are getting it, to maintain this slope, what you are getting, you are drawing a line, maintaining a slope of this one. Suppose I am drawing slope is 2 means this side is 2, this side is 1. So I'm just crossing it x-axis and y-axis so that you can see it from distance. Actually, in offline, I parallelly draw it in blackboard. So I am drawing a line in this way. In this way. This is a line maintaining a slope of 2. So similar to this one, you can draw maybe n number of lines, but parallel to each other. These are the line maintaining a slope of 2. Okay? Parallelly. This is the second step. Third step, what it talks about, that the feasible solution will be, or optimal solution will be at that particular point where this budget line, one particular budget line will become tangent to that particular shaded area, region of optimal solution, feasible solution. So the moment it becomes tangent, that will be your point where you will get your optimal solution. So in this case, in that diagram, you probably observe you are getting it in your, here, this particular area. And corresponding to that value, if you draw it carefully, you will get maybe some value, 178 or something, and this side maybe you will get maybe like 56 or something like that, maybe 56, and you will get it. If you draw carefully, you will get, and maybe 178 unit or something like that, unit of y and 56 unit of x in that way. If you draw that diagram carefully, you will get that value. In that way, we are doing it. I'm going back to that one, to PPT again. I believe you can see. Now, in linear programming, the optimal solution is defined by examining a set of possible alternative solutions and eliminating gradually the suboptimal one until the optimal is reached. Means in our diagram, I said that any points outside a particular constraint line is not giving you a feasible solution. So in that way, you are just excluding in that way. You are narrowing it down to identify your region of feasible solution. So it involves your 3 steps: graphical determination of the region of feasible solution, graphical determination of the objective function, and determination of the optimal solution. So how you are doing it? Here it is showing in a different way, just like in our isoprofit line, I made that slope, similar technique they are using it. But in our diagram, we show you how to find it out, that maximum and minimum, then join it. It is also maintaining the same slope. In other way, you can do it. A solution will be feasible when it satisfies all the constraints. All the constraints mean non-negativity as well as technical constraints. Here we have to satisfy both non-negativity and technical constraints. So how boundary set by labor? The equation was that 4x plus 1y is less than equal to 4x plus 1y is less than equal to 400. Okay. So here the slope is determined by input of labor in x, this is 4, divided by input of labor in y, this is 1. So 4 by 1, ultimately you are getting a value of 4. That is the slope. Now in this case, if you in our drawing also, this extreme point was 4, in x-axis it was only 1, and y-axis we identified 4 unit, 4 block. We joined it. Ultimately, you can see that diagram also. You will find a slope of 4 for labor. For capital, it was 1, because in both sides 3 blocks we identified. Same is the case here. Input of capital in x, input of capital, but divided by input of capital in y. So ultimately, slope is 1. And for this one, for land, it will be, slope was 2 by 5. You can see our diagram also. I am quickly showing you. You can see our diagram also. See here, this is the line which was having a slope of 2/5. This was having a slope of 4. This is having a slope of 1 because both sides 3 block. You see, here it is 2/5, 2, and this side is 5. In that way, we draw it. Okay. Same thing we are just discussing it now. Then we move on to second step, that is identifying the slope of isoprofit line. As I said already, unit profit of x by unit profit of y, 2/1. This is that one. So it is 2. And accordingly we draw it. And the third step is determination of optimal solution. The optimal solution will be found by the point of tangency of the frontier of the region of feasible solution to the highest possible isoprofit curve. Highest possible isoprofit curve. So in this case, you see in our diagram again, I am going back. In our diagram, you see these are 3 possible lines, 3, A, B, C, or whatever it is, 3 possible line, isoprofit line. But what is happening? We are identifying only that particular line, or even beyond that also, maintaining a slope of 2, you can draw maybe many other lines parallel to each other. But we are identifying only this particular line, which is tangent to this particular shaded area. Only that particular point we are just identifying. Okay. And accordingly, that corresponding value will give you your that solution. So optimal solution will be a point on the frontier of the region of all feasible solutions. So here, that corresponding value in x and y axis, if you draw it, you will find 56 unit of x and 178 unit of y. And ultimate total profit will be 290 under that given situation. If any of these values change, immediately your solution will also change. Even unit need to be produced for x and y will also change. By chance, if you change this labor and capital, but it usually happens before starting your production season, you know it. How many plots you have, how much land you have, how many activities you are going to adopt, or how many crop you are going to produce. How much amount you will be able to spend after machine or after capital. You have some idea, fair idea before starting production. You are arranging might be. And accordingly, if you quickly do it, you are getting a, and might be from past data, you have some idea about what is that unit profit of X and Y in general. But any of these values, if you change, immediately your solution will also change. Okay. Along with that, two other concepts are there. That is your, because I said at the beginning that your opportunity cost and other concept will come into picture in your, say, hiring of labor. So here comes your dual problem and shadow prices. In Ekocheni's that book, again, you will find further explanation. The basic problem whose solution is attempted by linear programming technique is called the primal problem. In our case, primal problem was maximizing Z, profit. Profit maximization is our primal problem. Corresponding to this particular primal problem, we will have a dual problem which will be cost minimization. In that case, it is a simple one. Converting these 3 technical constraints, it will become 2 in our conversion to a dual problem, where one will be for X, another will be for Y. There will be little bit conversion is there. You can see there. Okay. So it become 2. And left hand side, this land, labor, capital, 3 components you will find it, equation. Land, labor, capital, some values, and right hand side will be X value. And for another equation, land, labor, capital value, and right hand side again Y value. In that way you will get it. Each primal problem corresponds to a dual problem which will additional information to the decision maker. The nature of dual problem depends on primal problem. If the primal problem is a maximization problem, its dual is minimizing problem. Means in case of dual, our basic objective will be how to minimize cost. Cost of producing X and Y. Okay, in that way. Means your 56 and 178 will come into picture right hand side. How to produce 56 unit of X by using minimum by minimum cost for land, labor and capital. How to produce 178 unit of Y by minimum cost of minimum cost on land, labor and capital. That will be your dual problem. From the solution of dual problem, we can derive shadow prices of the factors of production used by the firm. Now, what is shadow price? So shadow price this is basically imputed cost or opportunity cost. You remember while discussing cost, actual cost and opportunity cost I discussed, and later on even implicit and explicit also I bring that value of imputed cost or implicit cost. You remember? Imputed value of family labor or implicit cost of family labor or imputed value of your own labor. It's quite similar with opportunity cost, what you are sacrificing. Okay, or opportunity cost. It is the return from next best alternative. I am reading it, after that I will elaborate. They are crucial indicator for the expansion of the firm. They show which factors are bottleneck to the further expansion of the firm. The shadow prices of the resource can be compared with their market price and help the entrepreneur decide whether it is profitable to hire additional unit of this factor or not, whether you are going to hire or not. Because these factors of production is not freely available. It decides how much profit of the firm will be increased if firm employ an additional unit of this factor. Say for example, think about hiring of labor for expansion. You want to hire labor. While hiring labor, what kind of thinking will come to your mind? You want to hire labor. What will come to your mind? Labor is not freely available. From labor market, you are hiring. First thing, obviously, you will look at what is that existing labor price per day. Suppose on wage basis you are bringing. So labor is suppose 300, hypothetical value, 300. Will you go for hiring that labor or not? Next question, it is 300 known to you. Then question will come, how much this labor can produce in my factory, where I will hire. Say I assume that this labor, if I hire by paying 300, he will be able to produce 200 output equivalent to 200 rupee. Suppose, will you hire a labor? Straight away no. So that is your concern. 200 rupee equivalent output he is going to produce and his cost is 300. I am not going to hire. So I am comparing with market price, his contribution. Suppose hypothetically now, assume that he can produce output equivalent to 400 units. You are going to hire him. Okay, 300 is hiring cost, 400 equivalent output he is producing. So you will be in beneficial. But your story is not ends here. Why? Here comes your shadow price. Means, is there any better alternative utilization of these resources? Opportunity cost. Opportunity cost of utilizing this labor will come into picture now. What is the next best alternative of utilizing that labor? There is under you, there is another alternative where this labor can contribute equivalent to 500 rupee. Then opportunity cost of utilizing this labor in your present work is 500. Is it not? So you are supposed to consider even that aspects also. And accordingly, you are going to take a decision. You might be hiring, after hiring also whether labor will be utilized here or in this activity. Or more labor will be hired to even compensate this one. So all these aspects will come into picture, and this you cannot avoid it in reality when you are just utilizing it. And as I said, that this is from your A-question, is that modern microeconomics, that book. You can go through it also. Might be this old version is available in online. Probably I am having that one soft copy, but in internet it is available now. Probably it is available once I mentioned it while sharing your this one maybe. And not only A question is this book, any book you can follow it. It's basic, only ABCD of linear programming. You yourself will be able to learn later. Okay. This is what. And some question will be there. And in addition to that, quickly, there are maybe 5 minutes more time. I want to ask you, this one I am going to share with you in your class material. Do not worry for that. But what is my more concern for me, that is your understanding, and second is your uh, any question. In case you have any question related to maybe from first lecture to last lecture, you can ask me. But my portion, anything, you can ask me. Because over the years I am teaching, I remember it. Anything I will be able to explain. In case you have. Because this is your last class, I do not think that I will get any more class here. But in case you have any question, you can ask me. Any question from my portion, you can ask me. I am downloading the attendance sheet. So no question, I am stopping the recording.